Okay, very good afternoon to all of you. So today we are going to have the second session of class 10 chemistry. We are going to continue with chemical bonding. Now in the first session, we had discussed some molecules and how their covalent bond formation takes place. We had discussed that in the first session. Now in that session, the examples which I discussed with you, one thing common to all those examples which we discussed, one thing which is connecting all of them is that they are all non-metals. If you just look back at whatever examples we had done in that particular session, whether it was classwork or homework, they were all non-metals. So we had in the class we had seen H2, O2 and N2, right? So these three examples we had seen in the class, H2, O2 and N2. So these three are all non-metal. Hydrogen is non-metal, oxygen is non-metal, nitrogen is non-metal. And in the homework I had given you chlorine, I had given you water, I had given you ammonia, I had given you CCl4 and I had given you CH4. So these I had given you in the homework: chlorine, water, ammonia, CCl4 and CH4. And these are all non-metal. Chlorine, in water you have hydrogen, oxygen. In ammonia you have nitrogen, hydrogen. In CCl4 you have carbon and chlorine, and in CH4 you have carbon and hydrogen. They are all non-metal. So all the examples of the first session, all of them, they comprise of non-metals. So it appears to be some kind of a rule that covalent bond formation will happen when the combining elements or combining atoms are non-metal. Now, what if the combining elements they are one metal and one non-metal, like one of them is a metal and one of them is a non-metal? Then what happens? Now, before I proceed, let me quickly tell you that if you are wondering, can two metals combine? If you are wondering, like, can you have a bond between two metals? See, bond between two metals is something not possible, but you do have things like alloys, but they are not considered as compounds. Alloys are considered as mixtures. So you have something called amalgam, which is alloy of any metal with mercury, and then you have so many alloys. It's a very common thing, but they are not considered as compounds. So that means when you have a compound, mostly it will be two non-metals, like hydrogen and hydrogen combine to give H2 gas, oxygen combines to give O2 gas, nitrogen combines to give N2 gas, chlorine combines to give chlorine gas, two hydrogen and one oxygen combines to give water, one nitrogen and 3 hydrogen combines to give ammonia, 1 carbon and 4 chlorine combines to give CCl4, and 1 carbon and 4 hydrogen combines to give CH4. So they are all example of non-metal and non-metal. So whenever a non-metal combines with another non-metal, they decide to do mutual sharing, and that mutual sharing is called covalent bond. This is what we have discussed so far. But suppose if it is a metal and a non-metal. Now in a metal and a non-metal, the situation is something different. Before that, let me first of all explain to you what is the primary difference between a metal and a non-metal. So you have all these things like their physical characteristics, etc., that you know. Density of metals is usually high, density of non-metal is usually low. I mean, these are all certain characteristics. But what is the definition? How do you distinguish between metal and non-metal? By definition, metal is something which likes to accept electrons and metal is something which likes to give electrons, and non-metal is something which likes to accept electrons. So metal is a substance which likes to give electrons to another substance. Non-metal is a substance which likes to accept electrons. And you will recall that when we were doing the classwork and the homework, in all the cases, you know, the two atoms which were combining to form a covalent bond, like they were willing to share each other's electrons, but there was a shortage. That is because there was a shortage. There was a shortage to get duplet or a shortage to get octet. But when you talk about a metal, it's the other way around. In a metal, there is no shortage. Metal wants to give up some electrons to achieve octet or duplet. So a non-metal likes to have some electrons for itself to obtain octet or duplet. A metal likes to give up electrons to achieve octet or duplet. So because of this fundamental difference, when a non-metal combines with a metal, instead of sharing, the metal will give some electrons to the non-metal, so that metal's job is done. It has given its electrons and got either octet or duplet. Non-metal got those electrons and it achieved octet or duplet, so its job is also done. So let us begin like this. Suppose, let us say, okay, so this is how uh, you show the transaction. Okay, the sodium is one metal atom, so sodium is 2, 8, 1. Sodium is metallic, so it is 2, 8, 1. Chlorine is 2, 8, 7. What I have done is that sodium I have drawn only the outermost shell. In sodium I have only drawn the outermost shell, so I have drawn one electron. So I have only drawn the outermost shell, and outermost shell has one electron. Chlorine, outermost shell has 7 electrons. 1, 2, 3, 4, 5, 6, 7. So it is 2, 8, 7. So sodium outermost shell has 1 electron. Chlorine outermost shell has 7 electrons. Now when the sodium and chlorine are about to enter into a bond, then what happens is that this outermost electron of sodium, it goes to chlorine. Now when the outermost electron of sodium goes to chlorine, then sodium's outer shell is no longer outer shell, it is gone now. So the second shell, which has 8, has now become the outermost shell, right? So previously the outermost shell of chlorine was the third shell, but that electron is gone. So now the second shell becomes the outermost shell, and it has got total 8 electrons because 2, 8, 1. So the second shell has 8 electrons. Meanwhile, an atom which loses an electron becomes a positive ion, which is also called cation. So sodium atom becomes sodium plus cation because it has lost one electron. So instead of sodium atom, it becomes sodium cation. So I have written third bracket, I have enclosed sodium atom, and on the top I have written a plus to suggest it has become a cation. Meanwhile, this electron has gone to chlorine. So chlorine, after getting this electron, has got its octet. And see, even sodium has got 8 in the outermost shell. Now chlorine also has got 8 in the outermost shell. So chlorine was 287, now it is becoming 288. And chlorine, you enclose it in third bracket and put a minus. So this plus and this minus, because they are oppositely charged, they will be held towards each other by attraction, because opposite charges attract each other. And that attraction is called a ionic bond, or why it is called ionic bond? Because it is based on ions. It is also called electrovalent bond. So this is the topic for today. So this is the topic for today, ionic bond or electrovalent bond. So whenever you have a metal and a non-metal who are about to enter into an association with each other, the metal will give up electron. How much? Till it gets either octet or duplet. So sodium, if it gives up 1, it will become octet. The non-metal will accept electrons. How much? Till it becomes octet or duplet. So chlorine will accept this electron, and from 287 it will become 288. In the process, the metal will become a cation, the non-metal will become an anion. And these two opposite charges, they will attract each other. And the attraction which they have for each other is called an ionic bond or a covalent electrovalent bond. Now you can just leave these two beside each other. You can just leave it like that. That is one option. The other option is you can draw one arrow like this and one arrow like this. That also you can do. So this arrow and this arrow suggest that they are attracting each other. So you can just leave these two beside each other, just leave it like that. Or you can draw one arrow, and these arrows will suggest that they both are attracting each other. So you have the option of either leaving it like that or showing two arrows to suggest that they are attracting each other. So that is how you will show a ionic or a electrovalent bond, right? Now you know very well that just like you had in covalent bond, it is not compulsory that one atom will come and another atom will come and they both will combine. You may have more than two atoms, right? So that can happen in case of ionic bond also. So okay, and one more thing is that when we show an ionic bond, you may recall that when we were showing covalent bond, we used to show electrons as dots. We used to show. So in case of ionic bond, because there are two different types of atoms, one is a metal, one is a non-metal. So there was a suggestion that you can show them differently. So the metal you can show it with a cross and non-metal you can show it with a dot. You can show both of them differently. This was a suggestion. Okay, So next we have magnesium forming bond with two chlorines, right? So this is magnesium. So the configuration is 2, 8, 2. So outermost shell has 2 electron. Then this is chlorine, outermost shell has 7. Another chlorine, outermost shell has 7. So magnesium will give 1 outer electron to each chlorine. So in the process, magnesium will lose both its outer electrons. The moment magnesium loses its outer electrons, what will happen is that magnesium's last shell will now become second shell. It has lost both the electrons to the two chlorines. So magnesium's last shell will now become the second shell. So now magnesium will have 8 in the last shell, and it has lost both the electrons, so it will become a 2 plus cation. So 2 plus, you can either write plus plus side by side, or you can just write 2 and then plus. That is, I think, better. Chlorine, each chlorine will get 1 electron from magnesium, so each chlorine will now become outer shell 8. So this chlorine outer shell 8 and this chlorine also outer shell 8. And in the process, just like magnesium has now become 2, 8, so it is a cation. So each chlorine has become 2, 8, 8. So each chlorine has become an anion. So you can do one thing, either you can leave the diagram like this, or as I told you, you can draw one arrow like this to suggest attraction and one double arrow like this to suggest attraction. This drawing double arrow is not a compulsory thing. Okay, it is not a compulsory thing. You can draw double arrow if you want to, right? If you want to suggest that they are attracting each other, or maybe if you draw it like this, I think this looks better. Yes, actually, the double arrow doesn't look very nice. I think this one looks better. So you just draw one arrow like this and one arrow like this. You draw one arrow like this, one arrow like this. So this arrow shows the attraction. So what I wanted to say to all of you is that when you have a ionic bond, one of them, or electrovalent bond, one of them has to be a metal, right? That is the one who will give electrons. The other one is a non-metal, the person who will accept electrons. And after the transaction has happened, they will both get either octet or duplet, which is stable, and then that opposite ions will attract each other. That attraction is called an ionic bond or an electrovalent bond. So in covalent bond, the mutual sharing keeps them together, and in ionic bond, the attraction of opposite ions keeps them together, right? So this is the topic for today, and now based on this topic, I am giving you some homework. Okay, all of you, these are the homework questions for the next session. These are the homework questions which has to be submitted before 9 p.m. tomorrow, 9 p.m. of Thursday. And the homework questions are lithium oxide. I'll give you all a suggestion. In case you cannot write the electronic configuration, just open your class 9 book, the atomic structure chapter, first 20 elements configuration is given. You can just take it from there. Right? Suppose you don't remember the atomic number of any element, just open your class 9 book, atomic structure chapter, and you will get the configurations of top 20 elements from there. So first one is lithium oxide Li2O, second one is magnesium oxide MgO, third one is calcium oxide CaO, fourth one is magnesium fluoride MgF2, and fifth one is sodium sulfide Na2S. So lithium oxide, magnesium oxide, calcium oxide, magnesium fluoride, and sodium sulfide Na2S. So these are the 5 homework questions, and you will have to attempt it and submit it before 9 p.m. tomorrow. So I'll conclude this session of ionic bond. Thanks a lot. Bye all of you.